So my name is Bob Brennan. I work for a company called Integrated Manufacturing Systems. We're based in the US. And we have an application that does wireless barcoding and data collection in factory floor. So factory floor automation, inventory control, that sort of thing. So the topic for today is just barcodes and the integration of barcodes and barcoding technology as a way to augment the input into your own business systems and give you some ideas if you're not used to working with barcodes, what they are, how they work, how to integrate them, some of the equipment, and so on and so forth. First, let's set some levels. Do you currently use barcodes in your applications? Anybody? Yeah. Ah, all right. And the second thing, I'm going to take a sense of the room here for a minute, because part of the conversation as well was around RFID in terms of the topic. Are people here to specifically listen and talk about RFID, or more interested in the barcoding side of things? And let me change it. Is anybody interested in RFID? 2. Okay. We'll get to that towards the end then. All right. So, kind of start the base case. What is the barcode? It's basically a machine readable format to put a piece of data in that you can use a piece of technology to get that packet of data out. Historically, they've been one-dimensional, and barcode reader would read this thing on the bottom that everybody recognizes, the zebra stripes. And there's a payload in there, right? So in this case, it's 1, 2, 3, A, B, C. It doesn't matter. So why do we use barcodes? Right? In our world, they allow us to get timely and accurate information on the shop floor into the system as quickly as possible with a user population that may or may not be literate, may or may not speak a common language, but they're the first people that know that a piece of data exists, right? So the faster we can get it into the system, the better it is, right? So it's repeatable and durable. So we can take a device, use barcodes, and have people processing transactions in real time that benefits the rest of the user population. Make sense? So there are a whole bunch of different types of readers, and we'll touch on this in a little bit. The typical reader that we use is either a USB integration or it's embedded integration, and both of those are by far the easiest. So if you haven't started a track into barcoding, those are the pieces of equipment that you want to work off of first. The extension of USB is also Bluetooth. They're basically the same thing in terms of how they're integrated. There's plenty of equipment out there that runs via serial interface, and for some folks in this room, I think are probably old enough to have gone through baud rates and parity bits and all of that. It still exists, right? And there's a lot of equipment, especially on in our world, like fork truck devices, computers, vehicle-mounted computers on fork trucks that still use serial interfaces. The vendors have made it somewhat easier to use, but it's a painful process. So if you can get towards Bluetooth or USB, you'll be a happier camper. So there are basically 2 general types of reading engines, okay? Most people are used to seeing, in the old days, you pull a trigger and a laser line comes out. It was a laser-based barcode scanner, okay? As equipment became, imaging became more and more popular, we had this intermediate step where there was a CCD device. It was basically like a one-dimensional camera that acted like it was a laser, but it didn't have the problems that lasers had. And then as you move forward, pretty much everything that you buy now is some form of an imager, right? An imager is just a camera, okay? So in the old days with the lasers, at the very beginning, they were pens. right? And the laser diode was hung off of a number of springs. And if people didn't want to work, what they do is they take the end of the pen, bang it, it'd start vibrating, and it wouldn't work. And they were so perfectly precision balanced, the thing would vibrate for 4 hours, and it wouldn't work. So on a Friday afternoon, oh, gotta go home. So the imagers to get us out of that one too. Okay. There are all kinds of form factors for scanning engines and scanning devices. On the left-hand side, are just everything that's a handheld, some of which are fixed mounted, some of which you move around, some of them are rings. Bottom right, a grocery store sort of attempt. In the top right, those 4 devices are all mobile computers that we use that have scanners built into them. Okay, so the idea that a barcode reader looks like one thing and one thing only, it's not true. So there's all kinds of equipment to match whatever your need is, whether it needs to be fixed, whether it needs to be mobile, how mobile, and then obviously that whole tie-in with how is it connected. So there are a handful of scan engines, and this is an important thing for folks that haven't done a project yet, especially from a customer's perspective, because they just look at a device and say, oh, it's a barcode scanner, and it will do everything, right? Barcode scanners have a particular design to work in a particular environment for a particular purpose. So a few of them to look at. A near range, or a standard range, it's kind of 6 inches to arm's length. So if the operator that's going to be scanning the barcode can kind of touch the barcode, it's probably the right device. Now, can they touch it all of the time? That's the first question. Second one is a far range, and it's kind of from arm's length out to 20 feet. And we're going to get into this distance thing in a little bit when we start talking about the physics of how this works. The third, and it's something that we use quite a bit in the factory and warehouse. We want somebody to sit on a fork truck. We want them to be able to shoot a pallet location that's 2 or 3 pallet locations high, or a mark in the ceiling that's 40 or 50 feet away. Right? And there are techniques to be able to do that, and we'll cover that. Some of the other use cases that we don't tend to use a lot, but I know are out there, high-density barcodes, so really, really tiny barcodes. And you can think of a barcode that goes on, say, a printed circuit board, right? Really tiny, small bits of data and a really small piece of material that you're printing on. And the other one is being able to use a barcode scanner outdoors in the bright sun. Okay. When we talk about the physics of how this works, bright sun makes it difficult for an imager to read. So you need specialized equipment to be able to read in bright sun or very bright working conditions. All right, we'll jump into the physics, I think. So in general, we have an imager, and this is one of the devices that we work on. I'll pass it around. We're going to play with it a little bit later on. But this has an imager. See the aiming dot up there? I'm going to create some feedback. This is an extreme distance cold storage mobile computer. So we can run this in a deep freezer for hours on end. It has a heater, it has a defroster, has an extra long range imager in it, okay? And just, if you want to see what one looks like. So when you pull the trigger on that, when you pull the trigger on it, the light comes out and it shines on the barcode, right? So we've got an aiming dot to know what you're looking at. Right? That generates a picture, okay, of whatever it's looking at. So whatever you've aimed at, we take a picture of it. It's the reflection of a barcode that's actually the data that we decode. So it's the inverse, it's what's read, the pattern gets recognized, and the device then figures out what it is that we're looking at.
Accidentally point to that's another barcode, then it also scans.
Yep. So the idea of tuning what we're aiming at and talking about techniques to get somebody to scan what they really mean, those are things that we go through in an implementation all the time. So a couple of techniques that we look at, the devices themselves have the ability to, like a gun, if you pull the trigger, it fires, okay? There's two other options for that. One is you pull the trigger and hold it, and it lights, but it doesn't read anything until you release the trigger. So I have a better control over what I'm reading. And the other one that's not so popular is you pull it once to turn it on, you pull it a second time to have it read. But that read on release is it's a win. Not all equipment has that. So, types of barcodes. There are hundreds of different formats of barcodes, okay? They all have their own way of being represented, but in general, we have two major components. We have the one-dimensional barcodes, things that look like the picket fence, and we have two-dimensional barcodes, the things that look like checkerboards stacked on top of one another. Okay, each one of those symbology is the term they use for the language of the barcode. And you can think of a symbology just like our languages, right? That German is different than English is different than French, but there's some common things and there's some things that aren't quite so common. Okay. So a symbology is really a set of rules. It defines the character set that you can embed in the barcode, right? Control codes, start and stop bits, check digits. It's a contract between the creator of the barcode and the reader of the barcode. So, as you move through a barcoding journey, if you know you're going to need upper and lowercase characters, or special symbols like pound signs and exclamation points and those sorts of things, you have to pick the right symbology. And if you are creating the barcode for your own use inside your business, that's one thing. If you're doing it as a result for compliance for somebody else to pick it up, that's a totally different thing. Then those two businesses have to figure out what it is they're going to do and how they're going to operate. So the way that the data gets put onto a barcode is interesting, and this is part of the symbology, right? There are barcodes where every digit that you're putting on has a unique set of bars, okay? So it's linear. There are barcode symbologies that interleave common letters and numbers so that you shrink down the width of the barcode, and it turns into like a compressed environment, okay? There are barcode symbologies that use lookup tables and do some fancy math about having multiple lookup tables, and all the odd ones come out of this table and all the even ones come out of that table. Uh-oh. Is that good? And they all have limited character sets. Did it turn off? Oh, okay. All right. You were doing something then. So it's important to match the symbology for what you're trying to accomplish. Okay. So in a barcode, one of the other things is kind of how do we size a barcode? How do we get it to be able to be read at whatever distance we're trying to read it on, okay? There's something called the X dimension of a barcode. And the X dimension is defined as the number, and this is, even though they call it mil, it's thousandths of an inch, it's a printing term. The X dimension is how many mil wide is the thinnest bar in the barcode, okay? Every bar in the barcode is either that width times 2 times 3 or times 4 in thickness, okay? And the bigger the barcode, and when I say bigger the barcode, the bigger the X dimension, the easier it is to read, up to a point. Okay? So on a two-dimensional barcode, its X dimension is actually the size of the smallest square, because all the squares follow that same methodology. Okay? So if you think about it, it's linear in terms of if I have an X dimension of a barcode, and it doesn't matter what the barcode is, if I double the X dimension of the barcode, right, I'm going to double the width of the barcode that's printed. So part of this is to try and maximize the size of the barcode for the piece of media that you are trying to put the barcode on. Okay? The cool thing about a two-dimensional barcode is if I double the X dimension, right, I actually make it 4 times bigger because I go 2 times in one direction and 2 times in the other. So we use a lot of 2D barcodes when we're trying to put things really far away. Okay, where we have a like a location hanging from a ceiling that's 30 or 40 feet in the air. We use a 2D barcode. We can take it in a small physical package, but the X dimension on that barcode is big enough that we can read it real simple with that kind of device. Okay. So I said the symbology creates the character set that's allowed. So tying up what we need in terms of types of letters and so forth for your processing is important. As the growth of a barcode, you're balancing how to create a big barcode to fit on a piece of media that's going to be useful to somebody, but not waste space on the label, right? So it's an interesting iterative process with folks that have never gone through this before. We're just going to put a barcode, and we're going to put this tiny little barcode on a pallet that's 30 feet away at a 60-degree angle to the guys trying to read it. It's like, you might want that. It's really hard. Physics is going to take over, and we're going to go through that in a second. Cool. Okay. So a 1D barcode typically, is this still okay? I moved it because I keep hearing my breathing through my nose, which I apologize for. It typically represents a single piece of data. Not all barcodes allow you to do control characters, like carriage control, line feeds, those sorts of things in the symbology. You can build out in one of those if you're going to programmatically refactor the data payload that's coming in. If you own the creation and the consumption of the barcode, you can make up whatever scheme you want to be able to build and concatenate things together, but that's on you. If you want to use the equipment to be able to process those carriage controls and that sort of thing, then you have to pick the right set of symbologies. All right. A 2D barcode is more like a paragraph or a document, right? So 2D barcodes are used when, for example, in the auto industry, if we're shipping parts to an auto supplier, then we'll do a 2D barcode that they have specified. And this is how it lays out. And they put all of the controls, they tell you the format. So we're going to use these controls to demark the header. We're going to use these things to demark the fields. We're going to use these things to work on the details. You can have iterative loops. So I can actually send the contents of a packing list as a 2D barcode. Okay? That's up to, if you're generating the barcode, it's up to you to follow the format. And on the reading side, you have to code all of the deconstruction of the data coming through. Okay? So creator and generator need to agree on the fields. It's implemented for the benefit of both of you. It's kind of like an EDI, same sort of Anybody do EDI, electronic data interchange? I have a painful yes. The whole concept of that is where you electronically trade. Here's my purchase order, here's my sales order, here's my advance shipment notice, and we talk to one another electronically about what has either happened or what we expect to happen, right? And we can match up what physically shows up versus what we electronically sent you, and be able to do things on an exception basis. The one exception to the kind of strict nature of a 2D barcode is the QR code, right? And the QR code is kind of this free-form thing. We see them all the time. They're all over the place. Since kind of COVID, they've taken off as kind of the marketing identifier. And they're all over the place. QR code started Japanese parts supplier for Toyota called Denso, created it, and it was sort of a free-form 2D marking for the parts that they supplied to Toyota. Okay. From there, it's kind of taken on a life of its own. They pushed the specification for it out into the public domain. Why that one versus any of the other ones isn't really clear, but that seems to be the market winner right now. So you can put all kinds of stuff in one of those, and as long as what you put in ties to whatever your people are scanning with, so now everybody uses their phone, right? So the intent of the scanner, the imager, when it sees a barcode in both Apple and Android, there's this concept of intent. What are we doing when we're presented with a piece of information? The default intents for those barcodes are to run a web browser, right? And therefore everything kind of ties together for you. So what could go wrong when you read a barcode? And this, we spend an awful lot of time on this. Reading a barcode is nothing more than an exercise in the physics of lights and cameras. Okay. If you don't have enough light, it doesn't matter what's going to happen. You're not going to read the barcode. Okay. The equipment's going to struggle. I mentioned before that the barcode, when the scanner illuminates what it's reading, it puts a lot of light on the subject, and it reads the difference between the light that's reflected back and the light that's masked by the bars. Right? So it's important then to have a lot of contrast between the black print and the white paper. Okay? We have a lot of customers that come in and they do visual aging on labels. So they'll use colored paper across all the labels. And some of them pick the most bizarre choices of colors to be able to read. And what happens is as soon as you go from black to white, that's the biggest amount of contrast, right? As soon as you start using blues and greens and reds, well, that contrast reduces. Therefore, the distance I have to be that I can get away from it reduces as well, right? And my favorite are people who print either on red paper or green paper, because scanners basically come in red and green. If you print on a piece of paper that matches the color of the scanner, it doesn't see anything. Right? So important conversations to have early into an implementation. So diffraction and deflection. So you can think if I've got a barcode right on the wall and I shoot it, I'm 90 degrees to it, all the light that comes from the scanner bounces off of whatever I'm looking at, comes right back to me, right? Perfect case. As that label starts to move up or down or sideways, more and more of the light is hitting that media, and instead of reflecting back to me, right, it's skipping off, it's deflecting off into the rest of the environment. Right, so there comes a point where no matter if you have everything else perfect, if you move a barcode too far in any direction, it's not going to be able to be read. Okay? Next dimension. That whole idea of how big the barcode is, the bigger it is, the easier it is to read from a distance. So if I have trouble with a particular barcode at a particular angle under a particular lighting condition, make the X dimension bigger, I can probably read it a little bit further away. Right? But there's a whole industrial engineering piece that goes into figuring out best case. Because ultimately what we want the end user, the person who's using the scanner, the person in our case that's a blue-collar factory worker, to continue to use the equipment and not get frustrated. And the way we reduce frustration is we make sure that we push as many things in their favor as possible, that when they pull the trigger and they read a barcode, it actually reads. You've all experienced it. You go to the grocery store. You have whatever it is you're trying to get through the grocery store. And they pass it, they do the swimming thing right down the, and one doesn't work. And they swing and swing and swing and swing. It's irritating for you, it's irritating for the person that's doing it, right? That same irritation travels out onto the factory floor with us, and we try and minimize that. Because there's nothing that we can do. If somebody's nice enough to pick up one of the devices and use our software, then we want to try and coddle them as much as we can. There's nothing I can do to force somebody to pick up my device. But once they do, if we have an issue, then we want to protect them as much as possible, minimize the things that we don't want them to do, and make sure that their experience is as positive as possible, right? So just the last couple of things. Quiet zones. Quiet zone on a barcode is the beginning and the end. There is each symbology has an amount of space it needs to know where the end is, right? Because if I look at a barcode and it's this wide, and I shoot an imager and it's only halfway up, I'm only looking at half of it, I don't want it to read that. I want it to know that it's reading the full thing. So there's start and stop dynamics on a barcode that keep it from falsely reading, okay? And just the wrong scan engine. I'm trying to read at far distance, and if I deploy a near-range imager, we're going to have problems. Okay. So, error correction. And this is, everybody needs an AI slide. This is my AI slide. Error correction is, we work in a perfect world where all of the labels look pristine, right? And they're not smeared, wrinkled, torn, smudged, print head damage, any of the sorts of things that can mangle a label, right? Well, we want to try and make sure that even if a label is somewhat damaged, that we can still read it, right? The difference between the $79 Amazon scanner that you'll find and wherever it is, whoever has my my device. I do. There you go. I'm paying attention. The two differences are really in, this is rugged. I can throw this across the room and it's not going to break, right? It's a rugged device. The other thing is all of the energy that goes into the imaging, right? The imagers on all of the industrial devices, and it doesn't matter the brand. This happens to be Honeywell, but there's 3 or 4 manufacturers that all compete and all have good products. The differences are the amount of smarts that the engineering put into the reading and the recognition of bad barcodes. So here's the AI pitch, and both Honeywell and Zebra are doing this. Okay. One of the biggest issues you have with damaged barcodes is you have a thermal label printer that generates these barcode labels, right? And if you end up with a label that somebody ends up not picking up correctly and it wraps around itself, and now I've got the sticky part going onto the print head. The print head of a thermal transfer printer, it looks like a toaster element, right? For 203 dots of electricity are what's used to heat and melt wax that gets pressed onto a piece of paper. That's how a thermal transfer printer works, okay? Each of those dots is addressable. That's how it figures out what to barcode, or how to process the barcode. The idea that happened on the floor typically means that somebody who has no experience at all cleaning or fixing barcodes says, I can take care of this, and takes out a pen, takes out a knife, takes out the back end of a spoon, and they rub the whole thing to try and get the gooey labeling stuff off. Well, if they damage the print head at all, it just means that those elements on the print head are shorted out. Right? So you can imagine that as a piece of paper comes through, that there's going to be lines where there's no print head because we're not heating it up, therefore we're not melting anything. Right? So you'll end up with a series of barcodes. Every barcode that you produce will be missing some number of pixels on one of the orientations, and it's the orientation perpendicular to the path of the paper. So what all of the industrial guys are starting to do is on a device-by-device basis, they are allowing more and more error to be captured and understood in the scan engine, okay? With the idea that if you are perpetually creating a difficult-to-read label, we can speed up the process of the first read by kind of washing that out of the system. So the AI piece of this is right now it's only the mobile computers, individual computers, that build up this knowledge library. Okay, and what everybody's working towards is if everybody in here had a scanner and went off and did a day's work in the factory, okay, all of you have a different profile of what images or what problems you've encountered. So what they're trying to do is take all of that, pull it back to a central server, create a common correction algorithm, and send it back out to the devices, right? And have that as an ongoing. So that's my shot at AI. That's that's their whole thing of here's how it's going to work. Here's what we're going to do. The other one I didn't put on, very common, and you can have the most perfect label, and I put it on a pallet, and the pallet goes to a shrink wrapper, right? And now I've got, if you've ever seen shrink wrap on a pallet, it gets taut, and therefore it's not smooth, it's all wavy. So now I have, you can think about it like I'm trying to read a barcode in the funhouse mirror, right? The one that makes you tall or small or skinny and fat and the whole thing. It's remarkable how good the modern scanners are at factoring that out. And the reason that they're good at it is because typically that interference, right, is uniform. Now, there's two things going. One, we're changing the look of the barcode. We're also making it way harder because it's opaque, right, to be able to read. So that, to me, and I've done this for a long time, to me, the ability to read through shrink wrap is kind of the cutoff between is the vendor's equipment any good or not, because that's a problem that everybody sees. Right. Okay. So, adjacent technologies are things like dot peening and scribing. Right? So dot peening is basically a way of generating, they look like 2D barcodes, they're dot patterns. And typically they're used to minorly deform metal products, sometimes they're in plastic. And then scribing is basically its character recognition. So I said earlier that most modern imagers are high resolution cameras. Most of the major manufacturers also have direct part marking capabilities. It's usually something that you have to add on. It's actually a software addition to the device. And scribing. So the devices are now, because they're cameras, capable of doing OCR. Right? So we've got devices that can read just words on a package, words on a label. The other implementations you'll see of that, lots of local municipalities now are using mobile computers to the parking attendants out in, do you have a ticket or do I need to write you a ticket? And what they do is they scan your license plate. That looks up in a database about are you a local or are you a tourist and whether we're doing this or that. So the idea that a barcode reader is this one-dimensional static sort of thing, that's not true. They're cameras, right? They're high-end cameras that can do a whole bunch of other things. And one of the other advancements is using the camera actually to take pictures. So we can deploy a device for shipping folks, for instance, or receiving folks. And they'll scan, 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 put stuff away. Truck comes in, they open the door, a bunch of boxes are damaged. They'll use that same imager to take a picture of what they're looking at and decide what they're going to do with the load. Right? So it's all out of one device. So they're multi-purpose. So how do readers work? Well, I had mentioned before that USB is the easiest way to go. USB includes Bluetooth. Bluetooth is nothing more than a fancy version of USB. They go in as a keyboard wedge. So anything that you type, you can scan. Anything you scan, you can type. Okay, and all the traffic and buffering is done for you. So earlier when we were talking about serial control and having to worry about X on and X off and buffers and overflows and all of that, USB takes care of all of it for you. So to the extent that you can use a USB device, especially if it's set up as an HID or human interface device, which is a keyboard, that's the ticket. Serial devices, like I said, sometimes you can't get away from them, but a serial device is can be a painful device to set up, especially if it's not something you do all of the time. So does anybody deal with serial stuff anymore? Yeah. And embedded devices. So, for example, this is considered an embedded device, right? The scanner in a grocery store is an embedded device, and all of that plumbing is done for you. If it's bundled together and you don't have to worry about the flow control and all of that, that works too. Okay. A lot of embedded devices actually have a web interface as well. So you'll see a lot of embedded scanners on like industrial automation equipment, where you've got a factory with a conveyor belt, and you'll have reading sensors and label printers and what are we making and how are we palletizing it and all that sort of stuff. A lot of those devices are just standalone devices, right? So that they're not tied into anything. They're kind of little computer systems on their own, little web servers on their own. And when they get a payload, you will either call into it or they will call out to you. Them calling out to you is usually the more popular approach. Okay. So how do you? So most of you guys said you use barcodes now. How do you generate them? What is it?
Barcode printers.
Barcode. So what do you use to drive it?
Software. Design it in, say, Barcode List.
Yeah.
So you use a tool. You use a tool. Anybody else?
Z-Inks DLL from Google.
Okay.
Generate QR codes.
Yeah. Okay. So in that case, you are using basically a third party. Yep.
Combining that with documents.
Okay. All right. Anybody else? Which one? Telerik? Oh yeah, perfect. Yeah, that's the commercial for the mothership here, right? There's basically three ways that we see people generating barcodes, right? One is using fonts. So if you are using Excel and you want to take a whole column of things and turn them into some barcodes, you can use a font. Right? The fonts are limited in terms of what you can do with them, but in a pinch they work pretty well. You can generate most barcode printers, including laser printers, on any of the major brands have barcoding capability built into it. You can talk in the native printer language and write a barcode out to them, right? So whether you're using a Zebra printer, a Datamax printer, an HP printer, an IBM printer, they'll all have specific language about creating barcodes in there. That's a rough way of doing it, right? That's a really rough way of doing it, right? And it's surprising the number of application partners that took that path in the early days and still are doing it today, where they standardized on a, for example, Zebra, and everything they wrote had Zebra printer language. Well, the issue with that is the only thing you understand and can be able to talk is the Zebra printer language, right? They're a great printer company, right? But they're not the only printer company, and it doesn't scale well, right? So we use tools like Loftware, Bartender, Nice Label. Those are maybe names that you've heard before. They're design tools that allow us to separate the creation of a label, right? What I said earlier is that our software is used to basically do inventory control in a factory, right? I don't want to have anything to do with our customers' label design, right? I want them to pick out and make it as pretty as they want. They do the front end, we do the back end, right? And the way that we work on that is through one of these tools that they basically work like a fancy mail merge, right? A printed label is like a mail merged document where you as the customer create all the prettiness around it, and you leave fields in for what's going to be human readable text that's coming out of your database and what we're going to barcode, right? And then I worry about creating the form or a file that has the data and the directives to one of these tools on how to create the label, right? It's loosely coupled, and it helps immensely in terms of separating the need for us to get involved in your kind of day-to-day operation. So just as a bit of advice, if you're looking at doing something, having a tool that's capable of doing all the barcodes you want and is a design tool so the graphic folks can do what they want, and then the tech folks can do what they want and what they're good at, that's a win. Yeah.
But they do have limitations, right? Because there's some overhead, so there could be performance issues compared to native.
Nothing will be faster than native, but the speed of the printer, right? The speed of the printer is infinitely slower than the ability of any of the server-based software products to feed them. So the issue really comes down, in my experience, always comes down to the printer being able to keep up, as opposed to the software being able to generate the request.
There's always the slowest element in the...
Yeah, because it pretty much works at human speed, right? It's 6 inches, 8 inches, 10 inches a second, right? In 1 second, I can create 20,000 label requests.
And another thing that I ran into, the speed was like 20 years ago.
Yeah.
I've seen once with a project they were implementing Nice Label, and they were not able to print as clearly as the native language of the printer could print.
Right now, we're doing a ton with Nice Label. I would just recommend that if you haven't looked at it in 20 years or 10 years or whatever it is, but and they're all competing with each other, right? So there's the ability to draw more and more performance both out of the network and out of the printers. You know, just in 5 years, what's happened is with any of this equipment, and the problem that we have is that life cycles for equipment roll insanely fast, right? And the appetite of our customers, who are manufacturers who put parts in a box, and any dollar that they spend that doesn't help put a part in the box directly, right? That's overhead. I'm considered overhead from a lot of our customers from the standpoint of, well, you're just an expense. It's like, yeah, I'm an expense that makes you a huge advantage in terms of putting parts in a box, putting them on a truck, and getting them built. Right? Try and do what we do on a piece of paper. Right? We'll beat anybody's paper-based system without, but getting that point across, really, really difficult sometimes. We work with a lot of kind of owner-operated, small and medium-sized businesses.
They buy their own printers, so they buy another one, and then suddenly it doesn't work. Nice label.
And well, for sure, right? And it's agnostic as well. I don't want this to turn into a Nice Label commercial, right? So full disclosure, we actually sell Nice Label on top of all those other ones too, right? What Nice Label did, and just as a product, what they did is they moved the idea that you design a label. Most of the original label design products, you design to a printer or a printer language, right? So if you designed a label for zebras and then you brought some Satos or Datamax printers in, it meant that you had to copy and paste, and I had a label for a zebra, and then I had the same label, right? Talk about code reuse, for different printer languages. What Nice Label did some time ago is they said, we'll deal with all of that. So you have one label design. So for customers that have lots and lots, thousands of label designs, as they're migrating to this, we're cutting things down by, a factor of the number of different printer languages that are there. So different ways of, kind of what do people do for printing. They'll embed it in a normal document. So like Word documents, Excel, Crystal reports. Anybody use Crystal reports or anything like that for reporting where they're trying to generate barcodes? Yeah. Right, so it becomes part of the environment. Generating barcodes that are scalable in some of those tools. Like it's just like not all of them use it as a font, but it's that same sort of concept. So being able to size things and get the right orientation, they can be prickly in terms of getting the barcode output that you want. QR generators, another way of doing it. The thing that where we live and die are label printers, and I had mentioned before we had direct thermal and thermal transfer. A thermal transfer printer is that printer where label stock comes through it. There's a ribbon, there's a print head. Print head heats the ribbon melts, fixes to the paper, and out comes a label. Right? All of those printers are capable of also using direct thermal. And a direct thermal printer or printing process is you chemically treat the label stock. Okay, some of you are old enough to remember thermal fax machines, right? Where the fax paper would come out and it'd curl up on you. All of those were thermal transfer. So there's a chemical bond in the paper. When you heat it, it turns colors. And the day that you print it, it looks really good. Right? And over time, as UV sunlight hits it, it fades to kind of a brown, a crusty brown, sort of. And at some point, the printed part and the non-printed part merge together, and you can't see them anymore. So applications for those, one, the supplies for that are slightly less. So if you're using millions of labels in a month, there's a supply or a savings built into that. Right? The downside is you need to turn your inventory really fast and get it out of your domain, right? If you hold on things for years at a time, especially if you have any sort of UV light in your facility, they just go to the point where they're not useful, they're not readable anymore. Okay. And specialty sorts of printers like cards and badges, any of the equipment that generates like your swipe to get into work, those operate mostly on a thermal transfer, right? And some of them are inkjet. Yeah, so wanted to show you a few just kind of pass these around. This shiny piece of material on the bottom, is a special piece of laminated paper, and it's called retroreflective. So remember earlier I was talking about as we shine the light on a label, and as we start to move on an angle, the light starts to dissipate, right? And less of it comes back to me. What retroreflective paper does is, and you'll see it when you're doing exactly what I want you to do, right? It looks like the back of a CD. If you took the back of a CD or a DVD and you turn it and you move it around, it looks like a prism, because it is, right? This has that same characteristic. So what happens is, no matter what angle I shine light at that, right, the prisms that are aligned with me shoot the light back at me, and very little of the light deflects or diffracts anyplace else. So at a great distance, on a steep angle, I'll get more light back. It makes things easier to read. So that piece of paper will allow that scanner that I have to read that barcode, open the door and go across the hallway. We'll get at least halfway if we don't get the whole way, okay? Downside to that material is it's expensive. So what we do is we use it for things that are permanent, like permanent locations, permanent markings on the floor or up in the ceiling. It's not something that you typically want to put on a product. We have use cases where we have really, really big things or awkward things that are dangerous to get close to, where we'll use that material. But when the cost of the product, a unit of one is tens and tens of thousands of dollars, the cost of a 50-cent label versus a half of a penny label gets lost in that math, and it works out. Okay. Some of the other just kind of show and tell items we have. These are barcodes, and the laminate, it's a laminated barcode that actually has a permanent adhesive to go onto a cement floor, okay? So we can do marking on the floor. We can put barcodes on magnets and put them onto dock locations and pallet locations. And this box of cornflakes has traveled all around the world probably 6 times with me. I think this is really cool. You're all familiar with the grocery store Aldi, I'm assuming, right? Yeah. So part of kind of the industrial engineering that goes into managing products as they flow through a supply chain is really making sure that the product is put together in such a way that if we're going to automate anything, that we all kind of agree on where the label is. So there's all kinds of marking instructions and pallet instructions and whatever. So whoever makes this, Millville, so I have no idea who they are, they created this really long, tall barcode so that no matter where you'd put the reader as this thing was going down the conveyor belt, it would read, right? Kind of cool. Obviously, that wasn't good enough for somebody, because on the other side, they have the same barcode, and it goes up the entire spine of the package. So no matter where you are, it's gonna read. Okay? I just thought that was brilliant, and just in terms of the height. Earlier I said that lasers basically cut across and it looks at the angle, or it looks at the differences between things, right? Lasers, the height of the barcode is just for the benefit of the person who's trying to scan something. Doesn't matter how tall the barcode is, okay? In a laser, I need one laser beam's width plus a pixel on top and a pixel on the bottom, right? So that's all I need. So the reason that barcodes started to grow is people with shaky hands, right, could read things, right? It's the same with an imager, right? As long as I can get the quiet zone on one side or the other, I can read it. So you might think that a barcode like this, if I said, we need that whole picture in the frame of the camera to read it, that, wow, we've got to be a really far distance away to get this whole thing. The start bit is here, the stop bit is here, and it's just across it. So I don't have to go the whole length of things, right? That was eye-opening the first time that I messed around with this. So thank you to the people at Aldi for providing a little bit of show and tell. All right, how are we doing? Before I jump into the other bit, questions, concerns, comments? All good? Yeah.
Based on that height, on a linear barcode, it's okay. But if you had a 2D barcode, would it make a difference?
Yeah, because the 2D barcode, it's the whole thing is the barcode, right? But that same deal I was talking about, right? Take the 2D barcode, and so using a piece of retroreflective material and move it across onto a 2D, I can create a really large, in terms of a barcode, 2D image that's 2 inches by 2 inches, and that's 100 and something mil of a barcode if I'm just using locations, right? So obviously the more data you put into a barcode, kind of the more stuff we're trying to fit, right? So the difference between saying I have a location L100 versus I have a 28-digit part number or a 40-digit description, right? The size is variable to the size of the payload. Yeah. Okay. And part of the RFID, which is a tangent to this, and I only have a couple of minutes, so RFID technology falls into two categories. There are tags, right? So an RFID reader is basically a radio that either receives a radio signal or creates an electrical field such that the tag gets excited and squirts out a radio signal, right? But it's a radio-based technology. The RFID comes in two formats. It is either the tag is powered by itself, so it's an active tag. So people that have car passes go through the hotel or the highway, they have a battery and they are constantly booming a signal out. Or you have a paper-based tag where it's just a circuit and it's waiting for an electrical field to excite it, to fill a capacitor. And when the capacitor gets to a certain point, it pops off, right? And you have to make sure that the reader and the thing are there. All your credit cards with chips, right? The chip is an RFID reader. So when you tap, right, that tap thing, you are not broadcasting anything. Regardless of what anybody tells you, your RFID cards in your wallet are not broadcasting anything, right? It needs a signal to be able to get excited and to read, okay? So there's two formats of that. In an industrial setting, what's become very popular is RFID is implemented in paper-based labels. So now you have printers that are capable of doing both RFID and a barcode on them, okay? Those pieces of equipment are in addition to any of the scanning sorts of things. So the ability to read is a function of either a handheld or a fixed reader. The fixed reader is either passive and waiting for active tags to come to it, or it's creating an aura of electricity that at the right frequency that the tag picks up and puts back. So they're complementary technologies. RFID has been around for a long time. It's gotten a lot of kind of bad publicity because lots of people were going to run and do it, and then it's a lot of work, it's a lot of money, And if you were doing it because your customer or supplier said, you'll do it and you'll eat the cost of it, like there was a lot of hesitation. And in the US, Walmart was really the driver for that. And so all of their suppliers were supposed to put RFID tags on all the pallets that were going to them. And without compensation for it, without help of getting the equipment together, and with very unreasonable deadlines. And guess what? It didn't happen. So where we see RFID right now is if you own the creation of the label or the tag and the consumption of the tag, and you can control that entire life cycle, those are the successful projects. Where projects are being used to go out to the outside world, that's where they're really difficult and less successful. Anyone doing, I mean, you guys said you were interested in it. Are you doing RFID anywhere? No? And nobody? All right, so. It's the same concept. Same concept. Yep. So. All right. I think we are probably pretty close. I think I'm a minute over. I apologize. So thanks for coming. Questions? I'm around the rest of the time. You want to chat or do a one-on-one sort of thing of what you were talking about or what your issues were. But thanks for spending a little bit of time with me. Thanks for coming and supporting the PUG Challenge. And if you got nothing to do in 2 weeks, come and visit us in Boston. Thanks a lot.